Hey guys, welcome back to the channel. In this video, we're going to be looking deep into the final stage of the data engineering lifecycle, serving data for analytics and machine learning. So let's get started. Now let us start with analytics. So analytics are the primary reason for the data transformation. Businesses require insights, dashboards, and reports. And in order to make that happen, we need the data to be trustworthy using validation, observability, so that we can monitor the pipelines, performance, perform optimization, and SLAs and SLOs. So 99% uptime and 95% defect free. Now let us look at the types of analytics, starting with business analytics. So this is the classic case: historical trends, KPIs for making strategic decisions. So what are the tools used? Tableau, Power BI. Now data is collected from warehouses and lakes. So data engineers ensure that they use semantic layers for KPI consistency and prevent them from changing from team to team. So the next one is operational analytics. So this is about making real-time insights for taking fast decisions. Examples are fraud detection, system monitoring, factory floor analytics. So this requires systems which have low latency and high concurrency. So examples are Kafka and Flink. So the next one is embedded analytics. So this is the type of analytics where it is directly baked into the app. So the direct end user can experience this type of analytics. So examples are smart thermostat energy usage, e-commerce seller dashboards, fitness app trends, and ride sharing driver performance. So such systems require ultra low latency and high interactivity so that they can provide instant insights to the end user. Now that we're done with analytics, let's move on to machine learning. So machine learning requires high quality data sets for model training, hyperparameter tuning, and real-time inference. So data engineers manage the feature pipelines and stores. Now let us consider ML serving patterns. So there are mainly two types: batch serving, online serving. So batch serving typically means offline training based on historical data, and online serving is the real-time inference. So let us take the example of Zomato delivery partner. As soon as you order the food and the delivery partner picks up the food from the hotel or the restaurant, we get a predicted time. So that is done by using real-time data. So it's a prediction. So it is basically machine learning. So that prediction is done on real-time data, and that is done through online serving. So now let us look at the technologies used in machine learning. OLAP systems are used for structured machine learning datasets, whereas Kafka and Flink are used for real-time pipelines, and feature stores are for reusable features. So this is one thing which is used in real-time data, as discussed in the previous slide. The major machine learning challenges are data freshness. So we need up-to-date data to make predictions. Considering the same example again as for the delivery partner, and drift and quality monitoring. So data quality is also an important point when it comes to machine learning. So let us look at a quick comparison. Analytics is used for dashboards, aggregations, business intelligence tools, and near real time. Now, whereas machine learning is for features, right? The tools used are Kafka and Flink, and we require ultra low latency and drift detection. Before we conclude, what are the key takeaways from this video? We understood that analytics is insights for decisions for business and for business intelligence, whereas machine learning is more of for predictions and automation. So that's it for this video. I hope that the concept of serving is clear. If you found it useful, like the video, share it with your friends, and also subscribe to the channel for more content. Thank you.